Okay, so now let's test out the cases. Which of the cases will help? Which of the cases will have the position of the CG to return the balancing toy back to its upright position? Okay, now just some notes. So I used a yellow line as a guiding line so that you can see, and the blue dot represents where the pivot is. So, and the position of the CG, we're going to test out 3 positions. One would be somewhere higher and the other one will be lower than the pivot. And another position will be at the pivot. Okay, so the first thing first, we have to always draw the weight. So I always tell students that you have to draw the weight to understand how the weight is pulling and causing it to rotate. So first thing first, we draw the weight from the CG. So we will be able to see that the line of action, you can see that the weight is in this. So it is at a perpendicular distance from the pivot. So it does produce a moment. So what is the direction of the moment that it will produce? So it will produce, you're right, it is an anti-clockwise moment. So it will cause the balancing toy to rotate anti-clockwise in this green color arrow direction. Now let's look at the second case. So let's draw the weight first. So as you can see, it is also at a perpendicular distance from the pivot. So let's extend the line of action, which is the direction at which the weight is acting on, and we can see that is a perpendicular distance, which means that the weight will produce a moment. So the weight will produce a moment about the pivot, which is actually clockwise. So it will cause the balancing toy to rotate clockwise. Well, let's look at the third case. The third case shows that the weight is right here from the center of gravity, and it also passes through the pivot. So as we can see, there will be no perpendicular distance. So if the perpendicular distance between the pivot and the weight is 0, so there's no moment produced. So with these 3 cases, which CG position will cause this balancing toy to return to its upright position? Is it case 1, where the balancing toy is going to rotate anti-clockwise? Is it case 2, where the balancing toy is going to rotate clockwise? And what about case 3? What's the effect of the CG exactly at the point of pivot? So if you say that it's case 2, that will return the toy back to the upright position, then you're correct, because the weight produces a clockwise moment, causing the toy to rotate clockwise back to its original upright position. Okay. Now let's look at another case, and see if it holds for the other direction. So let's just draw the weight, and we're also going to draw in the pivot. So the pivot is here, okay, and the weight, okay. So this will be my pivot and the weight from the CG. So the weight is always vertically downwards, so please remember that. And this is the pivot, which is exactly at the CG, and this is the weight. Now let's look at the moment produced by the weight, if there's any. So since the weight is on the right side of the pivot, you can see that, and the pivot's here and the weight is here. Now, it doesn't mean right side is always clockwise. So please just, for this case, the weight is pulling downwards on the right side of the pivot. So it causes it to rotate clockwise. So it causes the balancing toy to rotate clockwise. Whereas this one, the weight is on the left side of the pivot pulling downwards. So it causes the balancing toy to rotate anti-clockwise about the pivot. And whereas for this, because the weight passes through the pivot, there's no moment produced because there's zero, the perpendicular distance is 0. So there's no moment produced. So which case, 4, 5, or 6, will cause the balancing toy to return to its upright position? Right, so you can see that because for case 5, the weight produced produces an anti-clockwise moment, causing the balancing toy to rotate anti-clockwise, so it will return to the upright position. Okay, so this balancing toy works because the CG is below the pivot, and it will always produce what we call a restoring moment, returning it back to the upright position. So that's why it's really hard for it to topple. Hope it makes sense to you.